In order to express the direction of a vector that is given in a horizontal plane, we use some standards so that we can all agree on what we're talking about. The first standard we're going to look at is called the true bearing. And when we describe something as having a true bearing or something in a true bearing, we're talking about the direction of the vector being given by the angle between north and the actual vector. So, for instance, in this picture, the angle from north to the vector is 120 degrees, and we always go in a clockwise direction. So, a bearing of 0 degrees would be true north, and a bearing of 359 degrees would be 1 degree towards the west from true north. So if we are going to do these two examples where we draw each vector given by its magnitude and true bearing, we'll start with part A, where we're going to draw vector r, which is 2 meters at a true bearing of 60 degrees. So we will draw in our north and south east and west lines. And if we want a bearing at 60 degrees, we will come down 60 degrees, and then because the magnitude is 2, we will draw a line that is 2 centimeters long. So this is vector r, and vector r is equal to 2 meters with its bearing provided. Often when you write something as a true bearing, we always put in the third digit, so we would say 060. So it's just another indication that you're giving a degree using a true bearing rather than the second method we're about to look at. If we did the second example, we have vector A is 5 meters per second squared. So the meters per second squared are just the units of this vector. It's at 225 degrees. So we're going to go all the way around to 180, but then not quite all the way up to 270. So we're just going to come about halfway here, and it's going to be 5 units long, and we're going to label it as vector A is 5 meters per second squared. We could never leave that statement like that because the 5 meters per second squared is only the magnitude. So if we want to say that vector A is equal to 5 meters per second squared, we would also have to give the bearing, which is 225 degrees. So at a bearing of 225 degrees. The second type of notation we're going to use is called quadrant bearing, and when we give directions in this form, we measure them from the north or south line. So we say, which is it closer to? Is it closer to the north line or the south line? And then we say how many degrees it is, and is it towards east or towards west? So for instance, in this example, we have something that's 5 meters north, 45 degrees east. So we start at north and we go 45 degrees towards east. That's where the 45 degrees is going to be. And then the units, the distance we draw that vector is going to be 5 units. And then we can write that vector D is 5 meters north, 45 degrees east. So notice down here there's a second way of writing this. We could, if it's exactly 45 degrees between any of the compass directions, we can just say northeast. It's the same thing. For our example over here, we've got vector D is 2 meters south, 60 degrees east. So we're going to draw our compass. We're going to start at south, and we are going to go towards east, 60 degrees. And then we're going to draw our vector 2 units long. So vector D is 2 meters south, 60 degrees east. And then finally, vector F is 10 newtons west. If it's directly west, you can draw it right on top of the west line. So this is vector F is 10 newtons west. So if it's directly on top of north, south, east, or west, you can just say that. If it's 45 degrees between any of the two, you can say it as northeast or northwest, etc. Otherwise, you start with north or south and go either towards west or towards east, depending on what you're trying to draw. We can also convert between the two types of vectors. So if we have this example down here, vector v is 5 meters per second, 200 degrees, 210 degrees. That's a bearing, and we know that because it doesn't say north or south in the answer. So 210, if we think of where that's going to be, we're going to start at north. This would be 180, so it's going to be 30 degrees past 180. So this little section is 30 degrees, which means that our answer is going to be 5 meters per second south, 30 degrees west. In the next example, we're given the quadrant bearing. So we're starting at north, 30 degrees west. So there's our 30 degrees. Written as a true bearing, we're going to go all the way around, so to 270 plus 60, which brings us to 330. So 25 meters at a true bearing of 330 degrees. Another way to think about that is all the way around is 360 and we took off 30. So 360 minus 30 gives us 30. Thank you for listening.